Okay, what we're doing is showing different states of a door being open and closed using our Keyestudio, our smart home kit. We have not assembled this kit yet. I'm going to let the kids do that at the coding club. But what I'm doing is testing the code, the board, and the hardware to determine if it works, and also setting up a kind of a scene with our Lego minifigure. She's walking into the door. The code says when enter password is shown, press the A button. The password is AABB. And as I press the A button, you can see it registers A, another A, B, B, and then press A and B buttons together, and the door opens. And it says welcome. And I've added, you'll note in the instructions, the tutorial, it says that this LED group will operate. In fact, they did not write the code for that, so I had to add in the code that says turn the LEDs on in different colors. I wrote it to turn the LEDs different colors depending on whether the door is open or closed. From this board, we now send by radio transmission from this microbit over to this microbit, which then uploads the state of the door, open or close, to ThingSpeak on the cloud. That way we can analyze the cloud data. Now, get that clearer. Now, let's try that again and we'll see how that changes. Close the door, and after a few seconds you'll see the data change. And the way I've got this written, I think the door open chart shows a state lower when the door is closed, higher when the door is open, and the door shut chart shows higher when the door is closed. All right, we'll try that again. A, B, B, press them together, the door opens, and the state should change. Now so it's showing open now. So this is viewable from any computer if the data is shared. That's the whole idea. We're able to analyze the state of the door if it's shared. Now, I'm going to go away from ThingSpeak. I've said about all I want to do. Just basically, we need to clear these charts before we do another open-close session. You'll notice that as time goes by, the horizontal line lengthens. So if I come back in half an hour, my range of time here will be a lot longer, so these data points will be all bunched together. But it's nice to know that we can see on our chart when the door was open and when the door was closed, anywhere that we have internet access, if we can get access to these charts by using public view. Okay, so that's that. Now, here is the code, and I'm showing you that what I used was the map function right here to map the state of a received number. In other words, the microbit that is opening or closing the door according to the tutorial also sends a signal by radio to this code, which says when you receive a number, 1 or 0, make a data point on your graph chart in ThingSpeak. I'll put a link to this code in the description of this video, so when the kids actually assemble their house, this house, and they actually use a servo motor, looks like this. I'm using the Lego Technic servo motor just to demonstrate and test the system. It fits this green base plate, which also accommodates Lego bricks. The technical or mechanical parts match the bricks parts for Lego, so they all fit together. We can build a brick house if we want to and have a door that opens and closes using this kind of a servo motor. Servo is a motor that does different positions as opposed to a DC or continual circling motor like on a wheel on a car or a bicycle. That's a different kind of motor. An electric bicycle will have continuous turning motors. This is positional, like open and close a door or open a water valve on a gardening project when the sensor tells you that the soil is dry. Then open the valve on the garden hose so that you have watering of your garden. This is something we can do. We've got all these parts. Eventually we'll put that together and show you how that works. Now, the other part of this code is the part that does the send from this microbit. And you'll notice, by the way, where it says welcome, suppose I enter the wrong code. I'm going to do 3 A's and a B. It doesn't open at all. Error. Enter password. So, let's see if I can get that to be more visible. This is the wrong code. So we have the error note in this code. Again, I will put the description. I'll put this code in a link to it in the description of the video. I wish other people would do that because then you can actually see what their code is. Here are the instructions. This is getting to be a long video, but here are the instructions on how to build the house. This is the tutorial that I'm talking about. It says here that lights will shine in the house when you open the door, but in fact they didn't put the code in for the light shining, so I added the code so that the lights shine when you open the door. And then I'm going to show you I downloaded all of the code given by Keyestudio for the smart home. There's a file packet that's compressed. You open it up and it will give you code for each lesson. You just grab this hex file and drag it onto your make code for microbit, like right here. Just drag it onto this and it will open the program that they've written for each step of the tutorial, and we're only on number 2, password door. So we've got all these additional lessons to learn. What they don't have is data upload. This is not a Keys board. This is a DF Robot board. So Keyestudio isn't going to do this project. It doesn't use their hardware. It uses 2 different hardwares. But that's what we are, make code and hardware. So this is giving you an idea. Very nice tutorial. I like this company Keys because they give you very comprehensive tutorial. They show you pictures of what the final product looks like. They give you an earlier tutorial up at the top of this They give you a complete tutorial on how MakeCode works and how the microbit is designed. I've not seen any other manufacturers that give you a kit tutorial that includes everything about how MakeCode works, all the information about the microbit and MakeCode, and gives you samples of how it works. There's a lot to this. Okay, so there's going to be more when we go to our next lesson, which will be lesson number 3.